All right. There's, I think, just the three of us. So feel free to stop me at any point for anything. Question one, I actually did for the previous lab. Well, it's really like implementing the circular cube. Uh, so for question two, we are doing the coins problem, which we almost had done in lecture as well, right? But we'll kind of start from the start. So the problem again is you have coin denominations of 1 cent and 4 cents and 5 cents. And we have some kind of target. So maybe, for example, we want 8 cents. And what we want is the smallest number of coins that make up the target. So for example, for 8, this would be 5 plus 1 plus 1 plus 1. And that is 4 coins. So that is what we're trying to do. So the idea just mathematically is to say, okay, so what is optavai? So first of all, to define optavai, what we mean is, the smallest number of coins that make up the target I. And then the way we think about it is we say, okay, so what's the smallest number of coins that make up the target I? Well, say, okay, if you want to make up the target I, then you got to use some kind of coin. So either 1 cent or 4 cents or 5 cents, one of those kinds of coins definitely is going to get used. And then if you use a 1 cent coin, then optavai is the same as opt of I minus 1 plus 1, right? And the reasoning here is, well, like if you do use the 1 cent coin, then you need still to make up I minus 1 cents. And then you've used up 1 coin. So similarly, if you use 4 cents, then optavai is going to be this. And if you use 5 cents coin, a 5-cent coin, then it's going to be this. Again, the reasoning is you use a 5-cent coin, you need to make up this amount. And also you used the 1 5-cent coin. So the sum total of the number of coins is however many you need in order to make up I minus 5 plus the 1 that you used for the 5 cents. All right. So now what we want to do is we want to kind of combine those. So which of those is it? And the answer is, well, sometimes you have multiple options, sometimes not. But whichever one is the smallest, that's your answer because you want the smallest number of coins. So that's why in all, it's going to be the minimum of up to I minus 1 or I minus 4 or I minus 5. And then whichever one it is, you have the plus 1. Okay, so that's the equation. So now what we want to do is say, okay, so what's the number of coins? And let's send in the coins, I guess, like so. And what I'm going to do first is the recursive solution. And the answer here is, okay, so if the target is 0, then the answer is 0. And if the target is negative, then the answer is infinity. So this is just to say that we cannot make up a target that's smaller than 0. So this is going to be useful when we write up the recursive solution. You really could say, well, like a target of smaller than 0, it doesn't even make sense. So you can do whatever. It's just that that's going to be helpful later on. And now we're just going to say, okay, I'll try to compute op of I minus 1 and op of I minus 4 and op of I minus 5, and whichever is the smallest, that's the one that I'm going to return. So I guess I guess we'll do kind of the for loop. And we'll just try kind of every possible kind of coin. And we'll say, okay, so if number of coins for target minus coins, so minus 1, minus 4, minus 5, if that's smaller than what we've seen so far, then this is min coins. And now we just return min coins. So that's it. So the only thing that's really here that's going beyond just this equation is saying if the target is smaller than 0, then just return infinity. The reason this is useful is that if it happens that target minus coin is negative, that just means that you cannot actually use the coin. So what would be useful is to just say that this is going to be infinity. Okay. So that's nice. So one thing is that you would return infinity if you cannot actually make up that amount. Does that make sense to people? Well, if you have complaints, you can put a dislike on the YouTube clip, I guess, if you're watching it later. So, okay. So that's kind of the basic thing. I think in the first one, write down, so we wrote down the expression. So we wrote that. Here we want to list the coins that you need in order to make up that amount. Okay, and we've done several ways of doing it with houses. I'll do one of the ways with coins. So here, what we're doing, right, is we're computing just the amount of coins. We're not recording the coin that was used in order to make up that amount. So what I'll do is I'll just also record the solution here, right? So here, I am not recording what the coin is. I'm just returning min coins. I now want to use the coin. So, okay. So here, what I'll do is I'll say, okay, so I need an if statement now. So I'll compute this guy. So the number of coins required is like this. And I'll say if the number of coins that's required is smaller than min coins, then I'm going to use that. And I'll record that the coin that they used for that is coin. And I don't need that. And I'll just do a +1 at the end. Oh, well, do it in here, I guess. So, okay. So now over here, I've computed min coins and I've computed coin used. So what I'll do is I'll say, okay, so I want to return also the coin that they used. So one way to do it is to return those as a list, right? So here it's going to be some kind of list that's like this, and it's gonna have the coin used at the end, let's say. So how do I get this? Well, this is the list of coins that are used in order to make up the amount, in order to make up the amount target minus coin. So this function now also returns the list. So I'll just return the list. So I'll name it coins used. And now I need to increment number required by 1. And now I have coins used. So this is really coins, and here I'll name it coins used. Like this, in the same way that I record the coin. And what I can do now is I can just say coins used plus coin used, right? So coins here is the list of the coins that you use in order to make up this amount in an optimal way. And then after this for loop is done, coins used, this guy, is the actual coins that were used in order to make up the optimal amount. The plus here is just taking this list and adding this one element list to it. So it's going to be all the coins. That's it. So the way, I think if you just look at it, it's going to be maybe quite intimidating. The way to think about it is just like mathematically step by step, right? So if num coins rec returns, by the way, here I also need to return empty here to return something. So if what it returns is the number of coins needed to make up the target and the list of the coins used, assuming that that works, it's going to work, because here I'm calling this function and it's going to tell me, okay, if you're making up this amount, then you need this many coins, and those are the coins that you need. Okay. And if that's correct, then after the for loop is done, then coin used is the best coin to use, and those are the rest of the coins that this guy returned in order to make up the amount target minus coin. And that's it. So assuming that this works, that means that this entire function works. That's the entire magic of recursion. Is all you need to do is have a base case that makes sense, and then also have a recursive step that makes sense. You don't have to think it through to the end. Okay. All right. So this is like this. The next question is the segmented. So the question is like this, right? So we have a string and we want to know whether this can be segmented. So for example, here, if it's like apple, pen, this is actually a typo. Why didn't I update it? So here there is like a missing A, but if there had been an A here, then you can segment it as apple, pen, apple. Okay, so there is a missing A here. So this would be true. On the other hand, here, this is false because you are allowed cats and you're allowed cat, but if you say cat, then you get like san, which is not a word. If you use cats, then you can use and, but then you cannot have the word og. So there's no way to make it work. Okay. Okay. So how do we do this? So this is target, and this is words. So the idea is we want to say, okay, so if you can make up the target, then you are using one of the words. So if you can return true, that means that target is like words 0 plus target, everything up to length of word 0, starting from here, up to the end, or target is words 1 plus this, or target is this, and so on. Because like it has to start with one of the valid words, right? So it's the same logic. We just say, okay, so if it starts with words at 0, then it must mean that this can also be segmented. If it starts as words at 1, then this means that this has to be segmented. And if one of those returns true, then you can return true for the whole thing. So that's what we'll do. So we'll say for word rewards, we'll say, okay, so we'll say if target starts with, so you can use start with, that's like one of the built-in functions. You can just write it. So it starts with a word, then if you can segment the rest of the target using the word, then you return true. If not, you try something else. At the end, you'll return false if you've never managed to return true. So we also need a base case. And the base case here is just that if the target is nothing, then we return true, because you can always make up the empty string, but by not using any words. And that's kind of the true and the false. Yeah, that is the lab. All right. Do people have questions? Anything? Okay, there's something in the chat. Okay, there is a yeah, but that's from 626. I'm not sure what that was about.
I guess could you like
Yeah.
repeat that? Like, I didn't get like the where like if you found one word, then you know the whole thing can be segmented. Like,
You
wait,
don't, right? But
oh,
what we're saying is that if you can if it can be segmented, then it starts with one of the words, right?
so the entire thing has to be segmented from like
So like kind of what I'm
I'm
saying
not
is,
understanding the question, but
imagine that we have like, like apple, orange or something, right? So if it can, and imagine that the words are like apple and orange. So if this can be segmented, then either it's that it starts with apple, and then the rest of the thing can also be segmented, or it starts with orange, and then the rest can also be segmented. It does not start with orange, so that's kind of not relevant.
Okay, thank you.
All right. Okay. Do you have anything else? All right. So tomorrow's session is with Samantha, and then we'll be back on Monday. All right. See ya.